Free response question number 2. The figure below shows the graph of the velocity of an object moving in a straight line in feet per second. There are two parts which we're going to look at. During which intervals is the object, number 1, moving upward, 2, moving downward, and 3, at rest. Part B is asking what is the acceleration of the object when t is equal to 1.75 seconds, and part 2 when t is equal to 4.5 seconds. Let us explore these two questions. Free response question number 2, part A. Number 1, when is the object moving upward? Now recall that velocity has two parts to it, a magnitude and direction. So we are looking at the values when the graph is positive above the x-axis, and that occurs from the x values from 0 to 2, and again from 4.5 to 5. I'm going to highlight the actual graph in blue. So in this range right here, that is positive, it's all above the x-axis, and above here, this is all above the x-axis as well. Now, it might seem counterintuitive because the slope of this line is negative. It's going down. But remember that we're looking for values above the x-axis. When is this object above or positive? That's when it's moving up. So it's on this range here, and again on the range from 4 to 5. So we have 0 to 2 and 4.5 to 5. Continuing with our free response question number 2, part A, this time we're going to be looking at number 2, when is the object moving downward? And that occurs when the graph is below the x-axis, and that goes from 3 to 4.5. So in blue, I'll highlight this. All of this range right here, all these y values are negative. They're below the x-axis. That indicates that the particle or the object is moving downwards. So when the graph is below the x-axis, it indicates the object is going downward because the velocity at that time is negative. Therefore, the intervals are from 3 to 4.5. Continuing with free response question number 2, part A. Number 3, when will the object be at rest? That occurs when the graph is at 0, which is this interval right here. So when the graph is at the x-axis, it indicates that the object is at rest because the velocity is 0. Therefore, the intervals are 2, 3. Free response question number 2 continued, this time looking at part B. What is the acceleration of the object at t is equal to 1.75 seconds? The acceleration is the derivative of the velocity. Graphically, this means that the slope at any given point on the graph is the acceleration at that time. Therefore, when t is equal to 1.75, the slope is going down 3 and over 2. So, at t is equal to 1.75, the slope is negative 3 over 2 feet per second squared. Continuing with free response question number 2, part B. This time we're going to consider a second case when t is equal to 4.5 seconds. Recall that acceleration is the derivative of velocity. Graphically, this means that the slope at any given point on the graph is the acceleration at that time. So, here we have our point 4.5 right here. The slope, looking at it graphically, will be from negative 2 up to positive 2. There's my nice straight line, over 1. So we're going up 4 over 1. If we were looking at this algebraically, we could take the point negative 4, negative 2, and 5, positive 2. And plugging into the slope formula, we get 2 minus negative 2 over 5 minus 4 is 4. So what that means is that when t is equal to 4.5 seconds, the acceleration is 4 feet per second squared.